When we picture the backbone of the internet, we imagine something ethereal, but the reality is a heavy industrial substrate. Modern data processing relies on the hyperscale hallucination, treating the digital world as separate from the physical environment, resulting in massive, concrete monoliths venting exhaust into our skies. The traditional hyperscale data center operates on a strictly linear trajectory. It pulls massive amounts of electricity from the local grid, converts it into processing power, and generates intense thermal heat as a byproduct. That heat is then discarded through immense cooling and energy infrastructure, evaporating millions of gallons of fresh water in the process. This physical extraction creates a distinct geopolitical liability. When a nation relies on foreign-hosted cloud infrastructure to process its public or commercial data, it creates a sovereignty void. Citizens lose jurisdictional control over their own information. Consider the 2023 World Quo deployment in Kenya. Biometric data from hundreds of thousands of citizens was harvested and processed in foreign black box models. That data collection operated entirely outside state control, acting as a shadow node of national identity. Relying on an architecture that extracts local resources to power foreign-controlled servers is mathematically inefficient and a structural threat to national security. The engineering response to this structural flaw is the living machine, or the green edge model. It replaces the shadow node with active sovereignty. By physically locating air-gapped data servers within national borders, algorithmic processing remains subject to local laws and domestic oversight. These physical servers run on minimal ethical governance, or MEG protocols. This ensures that every high-risk data operation is transparent and verifiable by local authorities. To achieve this autonomy, the facility itself has to be redesigned from the ground up. We are going to look at how a sovereign node replaces reinforced concrete and heavy HVAC systems with botanical engineering and closed-loop agriculture. This diagram shows the contrast. On the left, the hyperscale model throws away thermal output as waste. On the right, the living machine captures that exact thermal output and uses it as the primary fuel for localized economic abundance. Building this node starts at the center. The core requirement for any sovereign intelligence system is a cluster of densely packed physical server racks. Modern hardware, like NVIDIA's Blackwell or Rubin GPUs, pushes processing density to the extreme. These chips are capable of exascale operations, handling over 2 quintillion calculations per second. That level of compute generates severe localized heat. Traditional air conditioning is physically incapable of moving enough air fast enough to keep these specific racks from melting down. The strategy is direct liquid cooling. Water pipes through cold plates directly onto processors, absorbing thermal energy instantly. Exiting this high-performance loop, the water reaches 50 to 60 degrees Celsius. Instead of venting, this hot water routes directly into an adjacent precision greenhouse. That thermal energy becomes the climate control system for cultivating vanilla planifolia, luxury vanilla. Vanilla is an exceptionally high-value crop that demands highly stable, elevated temperatures and high humidity. These precise agricultural requirements perfectly match the continuous thermal output of the GPU cluster. By acting as the thermal sink for the data center, the greenhouse entirely eliminates its need for traditional fossil fuel-based heating systems. This two-way energy sharing saves an estimated 22,000 cubic meters of gas per unit every single year. Engineers refer to this closed loop as the infinite money glitch. The facility completely zeroes out its massive cooling costs while simultaneously generating a continuous, high-margin agricultural yield. To house this integrated system, the Green Edge model discards high-carbon steel and concrete in favor of Dendrocalamus giganteus, the king of bamboo. This organism grows up to 1 meter per day. That renewal rate creates a continuous supply chain for raw building materials without requiring deforestation. Its load-bearing performance comes from its dense outer epidermis and vascular bundles, providing a tensile strength of 163.8 megapascals, rivaling mild steel. The segmented internodes act as naturally engineered short columns, resisting buckling to bear the weight of the vaulted shell encasing the core. Prioritizing this biological material turns the data center's physical footprint from a heavy carbon emitter into a high-performance carbon sink. Utilizing this material requires navigating a strict botanical constraint. the 40 to 80-year gregarious flowering cycle of the giant bamboo. During this flowering phase, the plant consumes massive amounts of stored energy. Its lignin levels drop rapidly, which severely weakens the structural integrity of the culms. To guarantee load-bearing stability, engineers must cut the bamboo exactly at peak maturity, usually between 3 to 5 years of age. This chart tracks the silica concentration over time. Harvesting pre-flowering locks in the maximum concentration of silicon dioxide. At 3.4%, this silica hardens the bamboo, providing the edge node with natural fire resistance and protection against microbial decay. By aligning construction schedules with precise biological cycles, engineers elevate a fast-growing grass into a high-grade material capable of protecting critical state infrastructure. When we zoom out from the physical mechanics, we can evaluate the macro-financial architecture of the completed living machine. This financial waterfall chart displays a sharp asymmetry. A pilot node requiring a $364,000 capital expenditure generates a projected asset valuation of $2.8 million. That multiple is driven by 4 distinct revenue streams. The first 2 are the premium pricing commanded by localized sovereign AI hosting and the continuous high-margin sales from the agricultural yields. The valuation is finalized by monetizing carbon sequestration credits from the structural bamboo shell and by providing data sovereignty consulting to other entities using the MEG frameworks. This extreme multiple demonstrates that systemic, multi-species engineering simply out-earns isolated, single-use infrastructure. As AI models accelerate, owning localized compute is the only mathematically sound way to protect regional stability. This is the principle of reverse provenance. True digital sovereignty requires absolute control over both the algorithmic logic and the physical substrate it runs on. Moving away from the hyperscale model to the sovereign edge satisfies both ecological demands and critical defensive strategy. Afrocentric sustainable luxury provides the most mathematically rigorous and profitable infrastructure logic for the 21st century.